So this is a problem, that is, you are asked to find the electric field due to a charge distribution with spherical symmetry. So spherical symmetry means you can assume a sphere, a ball, and the density, the charge density or volume charge density is given with rho v. That means per unit volume, the charge concentration per unit volume is given as rho naught r by capital R. So r here is the radius, and when you assume any point, the distance from the origin is given by small letter r. So for example, if this is the point P, then this will be r. If I consider a point Q outside the sphere, it will be again r. Okay, so the point small letter r means it is the distance of a point from the origin. Okay, that will be variable. So when you have to calculate the electric field, you just realize which law or which equation to apply. So you know that something connecting charge or charge density and electric field or electric flux density is Gauss law. So first to recall what is Gauss law. Gauss law is del dot D is equal to rho V. Again, D is given by epsilon 0 E. So again you can write del dot E is equal to rho V by epsilon. Okay, so this is the equation which you have to find out, or which you have to apply. So again back to the problem. Here the issue is that for a distance till capital R, the charge density is a value, and when the R is greater than R, it is another value. So it has two conditions, like when point is within that sphere, that means case 1 is when R less than R, and case 2 when R greater than R. So this problem should be done by considering the two cases, when the R is less than R, that is when the point is within that capital R radius, and when the point is outside that distance R. So we are taking it separately and applying Gauss law. So let's proceed with the case 1. When R less than R, again psi is equal to surface integral of d dot ds, that is epsilon naught surface integral of E dot ds. As we can see that it's a spherical area, you can take the plane in theta phi plane. So ds will be r d theta into r sin theta d phi. So ds will be r square sin theta d theta d phi, and this is along unit vector r. As we all know, theta phi plane means it is the unit vector normal to it is ar. Theta phi plane unit vector normal to it is ar. So you got ds, and then what about E or D? As it is a spherical symmetry, the flux will be radially outwards. So again it will be along the radius. So you can take it as, say, E can be taken as ER into unit vector AR. Now coming to charge Q, it is the volume integral of rho V dV. Again rho V, when R is less than R, throughout this is the charge density. So you don't have to take any other case, this is the charge density. So it will be rho naught into R by capital R into dV is given by, in spherical coordinate it is R square sin theta dr d theta d phi. You have to take the volume integral. Okay. And limits you should understand, R is varying from, it is a point within the sphere, so R will be less than R. So it will be, R will vary from 0 to R, theta will be varying from 0 to pi, and phi will be varying from 0 to 2 pi. If you are considering a sphere in general, if no conditions are given, From the coordinate system, that diagram itself, it is clear. Theta, the maximum variation is from 0 to pi, and for phi variation is 0 to 2 pi. So you proceed with the integration. U naught rho naught by capital R into integral r cube, r into r square, so r cube dr, and the limit will be 0 to r into integral sin theta d theta within the limit 0 to pi and integral d phi 0 to 2 pi. So it will be rho naught by capital R into r raised to 4 by 4, applying the limit. Then sin theta on integrating you get minus cos theta. Minus cos theta, applying the limit you get cos 180 is minus 1. So it will be minus of minus 1. So that is 1 minus minus 1, that will be 2 into 2 pi. So this will be the answer. 4 will get cancelled and you get rho naught pi r raised to 4 by r. Rho naught by capital R into pi into r raised to 4. This is the total value of charge Q. Now what you have to do is you have to equate this with your psi value. Q is equal to rho naught pi r raised to 4 by r is equal to surface integral of d dot ds. We have got till this, and again the thing is you have to integrate this. On integrating, you if you integrate this, we can get the value as 4 pi r square. If you want, you can do it. Otherwise, you already know the surface area of a sphere will be 4 pi r square. So either you can put the limit here for integration, theta you can put from 0 to pi and phi you can put from 0 to 2 pi. Either you can integrate that way or you can directly substitute 4 pi r square. So here you write epsilon 0 er into 4 pi r square. And now you need to get the value of er. Er will be, pi will be cancelled, this r square will be cancelled, and you get er will be rho naught r square by 4 epsilon 0 capital R. Also, electric field E will be, this is the radial component, that means how to write the E electric field as it is a vector, you should write it as rho naught r square by 4 epsilon 0 capital R into unit vector AR. But the problem is not yet complete. Why? Because this is only case 1. Case 2 means if the point is outside the capital R, or if the point is outside that radius defined as capital R, the value will be different because charge is concentrated only till the radius R. So outside that point the value will be different. So this is the answer for case 1 only. So for case 2 again you have to do the same way. So case 2, when R is greater than R, same thing, psi, that is equal to volume integral of rho v dv. Here you have to take only till capital R because after R there is no charge. So because of that you just have to take value till R. So again what you are writing is rho naught R by capital R. This is the rho v, and radius will be again r square sin theta dr d theta d phi. Phi will be varying from 0 to 2 pi, theta will be varying from 0 to pi, r will be varying from 0 to capital R. In the last case it was small r because it was within the radius capital R, but here as it is outside the capital R, the maximum charge is only till capital R. So here you are taking the limit as capital R. That is the only difference. And you are integrating, you get it as just like the last case, rho naught by capital R into integral R cube. Now the limit has varied 0 to capital R. Rest is different. As you might be remembering, integral of sine theta, that will be minus cos theta. You are putting the limit 0 to pi and phi varying from 0 to 2 pi. So you will be getting rho naught by R into R raised to 4 by 4 into 4 pi. 2 into 2 pi, that is 4 pi. Again you will be getting 4 get cancelled and rho naught pi R cube. This is the answer, and this you have to substitute with psi, which will be epsilon E dot ds. That will be epsilon naught into ER into 4 pi R square. That is same in all cases, because R, whether it is less than R or greater than R, area will be same, that is 4 pi R square. You are equating to this rho naught pi R cube, and you will be getting ER as pi get cancelled, rho naught R cube divided by 4 epsilon 0 R square. So when you write vector E, it will be rho naught R cube divided by 4 epsilon 0 R square into unit vector AR. So your answer will be having two parts. When R is less than R, this will be the electric field, and when R is greater than capital R, this will be the answer. So you have to, there are similar problems like this. For this you have to take as two different cases and calculate separately.